This is the GreenPAK voltage shield for Arduino based on the SLG46826 mixed signal programmable matrix from Dialog Semiconductor. It's designed to monitor internal and external voltages on the Arduino and report errors via an error indicator and also via a logical 1 on an Arduino pin. You could connect this to an ESP8266 and use it to remotely monitor the status of an Arduino Uno or a different Arduino if you chose to. So right now you can see the only indicator we have lit up is the 5-volt enabled, and that tells us we have 5 volts coming into the board. And you can see that right here. We're actually bringing in 5 volts from this little power supply. And you can see that the error indicator is not on. The enable indicator is on. So if we dial the power supply down slightly, here we're at 4.9 volts, 4.8, 4.7, 4.6, and right around 4.4 volts. Anything less than 4.5 volts, we're going to get an error, because 4.5 volts is really the minimum you would want to run a Arduino that runs on 5 volts. So if we dial this back up, we see that the error indicator goes away. So what happens is you get below 4.5 volts, the Arduino, or I'm sorry, the programmable matrix recognizes that, compares it to a known good level, generates an error indicator, and also generates an error onto pin D7 of the Arduino, which you could read with the digital read. So what we're going to do now is switch this board so that we can provide a VIN input. We will change our setup here and bring up the 9 volt. Oh, it's 3.3 volts. Okay, so we've got it set for 12 volts now through going into VIN, so we're going to power it up. And you can see that now we've got another indicator. We've got the 5 volt enabled, which tells us we have a good 5 volts, and we have a VIN enabled indicator, which tells us that we're powering the board by VIN. So the VIN indicator only comes on above 6.5, 6.4 volts. Anything less than that, and we actually generate an error, because 6.5 volts is really the minimum at which you would run an Arduino on VIN. I believe the Arduino organization specifies 7 volts, but 6.5 volts is really a valid voltage for this. So what we'll do is dial this down and see when our error indicator comes on. So we're at 7 volts, 6 volts, and we see we've got an error now, and the enable indicator has gone away. You can't really tell it on the video, but it has gone away. So now what we'll do is we'll just dial it up and see when it comes back on. So there we're at 6.4 volts, we still have an error. And now at 6.5 volts, the enable indicator has come on, although not as bright as it would be at 7 volts, and the error indicator has gone away. So the internal voltage comparator of the SLG46826 recognizes that we are below 6.5 volts and throws us an error. And again, this board can handle voltages all the way up to 12 volts, which is the recommended maximum voltage for the Arduino. So now we will do an external voltage comparator. We can measure voltages up to 5 volts and compare them to an external reference. And so what I've done is I've connected the external voltage reference here, which is this pin on the left, to the 5 volt rail. So right now it's reading 5 volts as an external voltage reference. And I've got the other pins on the voltage reference, the voltage comp, connected to my power supply up here. So what we'll do is we will turn it on, and now we're pumping 5.1 volts into that external voltage comp, and you can see that the error indicator has gone away for the external voltage ref. So what I'll do is turn it off, and you'll see the indicator comes back on. So we'll turn it on, and we will dial it slowly down to something under 5 volts, and we should get an error. Okay, we're on, and I'm going to start dialing it down. That's there we go. Once we get below, just below 5 volts, we start tracking an error, and there it is. That's at 4.9 volts. So that's our external voltage reference. We can measure, we can generate an error based on an external voltage reference if we choose to. So the other functionality of this board, the other primary functionality, is the bidirectional level shifting. I'm going to go ahead and turn this back off. And what I have done is connected the level shifters I've looped them back in from the external ports here to pins 7 and 8, which I have set up as a software serial connection on this Arduino. And I've also connected them to the serial terminal of my Raspberry Pi. So what I will do is bring up my Raspberry Pi command line, and I'm going to have to plug this Arduino back in. So what I'm running is a program, sketch on the Arduino that looks for a signal on the serial port at 57.6 baud from the Raspberry Pi, and if I send a signal out from the Arduino, the Raspberry Pi will reply and say, yes, I received your message. And this will prove to us that we have bidirectional level shifting communications going on this board. So we will start the program on the Raspberry Pi, and my Raspberry Pi is not responding. Oh, there it goes. Okay. It's running really slow right now for some reason. Okay, so let's try that again. Load up our program. Okay, so the Raspberry Pi said to the Arduino, say something. And now if I say something from the Arduino, you can see we get a response. The Raspberry Pi said, you said hello to me. Okay, so we do have bidirectional communications going on. So now if we remove one of these pins here, or if we, better yet, let's reverse the jumper. So now we don't have the bidirectional communication configured correctly. And if we say hello, we get no response. Okay, so that is the basic functionality of this shield. This shield also has additional functionality in that each one of the outputs from the Dialog Semiconductor Programmable Array are brought out to this pin header here, and there are jumpers on the bottom, solder jumpers, where you can disconnect all of the external circuitry from that SLG part and connect jumper cables, jumper pins or wires directly to it, and you could use this as a development board for that chip. If there was something you wanted to try, some functionality you wanted to implement, you could disconnect those solder jumpers on the I/O pins that you wanted, which would disconnect the rest of the circuitry on the Arduino, and then you could jumper these pins directly to whatever other device or other circuitry you wanted, which would allow you to use this board as a development board. So this board is programmable on the Arduino, not in this revision. This is revision 2, and revision 3 has a jumper right here that will allow you to switch it from run to program mode, which allows you to program it on the Arduino. There is an example sketch available, and so that's it. I enjoyed building this. I enjoyed participating in the eFabless challenge for this board, and I hope you enjoy using it.